As we continue here with Genesis, we have gone into this thing for about 3 hours now, and we're finally to verse number 1. In the beginning, God created the heaven and the earth. Woo! Okay, we've completed it. Now, as we talk about this, we are going to get into the idea of creation versus evolution. Hopefully, it won't take us too terribly long to keep digging into this. But as we get going, I do want to teach you guys some basic facts about evolution, because in my experience, Christians are woefully ignorant when it comes to creation and evolution. Because they hear the word evolution and they have an instinctual guttural reaction, evolution bad. Okay. I sound like I'm bad, but I really am coming from a good place, I think. Anyway, let me give you a slight bit of background to help you understand where this problem came from. Okay? Back during Darwin's day, I trust I don't need to introduce who Charles Darwin was. There was this idea that God made all species of animals exactly as they found them at that time. Okay? So if we assume a 6,000-year-old Earth, okay, so we're looking 4,000 BC, creation of the world. You come forward all the way up here to the 1850s. Do you think animals changed somewhat in that time? Yes. Okay? So you can look all over the world. You can find different animals. You can find how they've changed. In the studies since Darwin, you can actually see how new species arise and all of that wonderfully good stuff. But there was this belief that all animals were created in the form that they were, and they lasted up till the 1850s when Darwin was writing. So Darwin had a problem with that, obviously, because that wasn't scientific, that wasn't true, that wasn't biblical. So Darwin writes a book called The Origin of Species, and what he has noticed is that on the island of Galapagos, you have a finch. And as you look at that finch, depending on the island the finch is trapped on, the finch may have a world of different characteristics. So it could have kind of a bigger beak, it could have a smaller beak, it could have a long beak, it could have a squatty beak, all right? It could have any variety of those things. It could have a tall beak. It could have a short beak, like stubby. I mean, all these different types of beaks. And what he noticed is it had to do with what they were eating. All right? So what he assumed is that it would be logical to conclude that all of these different finches, with all of their different beaks and the different stuff they ate, all came from a common finch ancestor that somehow got trapped on that island, who knows how many years past. So somehow finches got to the island of the Galapagos, and then various finches got trapped on different islands in that system. Some fed on grains, some fed on other things, and so based on climate and food and all that stuff, their beaks change. Okay, so this is what he observed, but he assumed that if you have all of these birds coming from a common bird ancestor, that maybe if you started tracing it back, you could then say, well, maybe birds and some other animal shared a common ancestor. And maybe if you keep going back farther and farther, maybe we could have this pattern emerging. Okay? And so ultimately what he's saying is, if you keep tracing this logic back, so this is what he observed, maybe you could get all the way back to some common ancestor of all animals. And beyond that, you get some common ancestor of all life. Now, does that kind of make sense? Okay. And so what he's trying to say is that whole belief that God made every species exactly as you see it today, that's not what we observe. That's not real. But what he did is, in taking it back to say, I think species changed based on their environment, he went so far as to say, I think pretty much everything has changed and adapted to its environment to the point where it becomes new creatures. Okay? Now, the Bible would teach us that everything reproduces after its kind. We'll get to that in a little bit in Genesis. That's a little bit ahead of where we are. As you try to nail down what a kind is and all that wonderful stuff, it's a little harder to talk about. But you can see where Darwin was right in a little bit, but he extrapolated out too far. So this little thing that I've just described, this thing with the finch beaks, this is what we would call micro or small evolution. what he described in this tree of life drawing would be macro or big evolution. Okay? The reason I explain this is because microevolution happens. There's no doubt about it. Like, this is actually the observable one. What's really cool is you can actually watch this happen in real time, where you study over the course of a season or two, you will see animals adapting to their environment. But specifically with the Galapagos finches, they will adapt back once the environmental change has ended. So they will adapt to their environment, their beaks will change, or certain ones will prosper, and then once the environment changes back, so it's no longer a drought or whatever, they have the ability to adapt back to where they came from. So they can fluctuate. So God has built in quite a bit of variety in something like a finch, so it can adapt. But again, if you were to chart it out, it would look almost like this, where it's like, here's change, 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 the environment changes back, and it comes right back to where it was. That's kind of what this would look like on a graph. All right. The other thing to keep in mind, with all the experiments that we have done, it's almost like there's a box. And so what we would have is, let's say we have a bacteria, you will see all sorts of change inside this bacteria as they adapt to their environment. But what scientists have started to observe is there seems to be like this invisible barrier that kind of keeps it all contained, and so it never becomes something different than that. It can become a new species, it can become all sorts of new things, but there's no point that we've observed where it's broken through that barrier and become an entirely new life form. It's always a bacteria, it's always a dog, always a cat. You can look at the fossil record and start trying to make assumptions, but that's exactly what they are, assumptions. There's so many holes in the fossil record, we can't really use it to definitively prove anything. But we've noticed, like, there seems to be this invisible barricade. And so there's this guy by the name of Lenski. All right, Lenski, I believe since, at least the 70s, if I'm not mistaken, he's been doing evolutionary experiments on bacteria. And he is noticing all sorts of evolution taking place. So what he does is bacteria go through multiple generations a month. So you can trace basically what would be the equivalent of thousands, if not millions of years of human evolution very quickly in the lab, because bacteria have such a quick lifespan. And so what he's done is he's actually saved generations worth of bacteria in his basically his fridge. And so he's been doing these experiments for a long, long time. So he can pull out, if we were looking at this evolutionarily, he can pull out, this generation right here, which on the evolutionary scale of things would have been millions of years ago. He can pull it back out of the freezer and he can compare the genetics of that to the genetics of a modern day, this level. And so he can compare how these bacteria have evolved. And what typically happens is it's actually a what's called a devolution. It's a degrading of certain genes. And so there's some that he's noticed that this certain one it will grow 100 times faster than others. And what it is there's a certain gene that limits its growth, and that gene clicked off. And so after this certain point in the population, like, it just started growing massively because that inhibitor gene turned off. And so what God has done is he's built into these creatures this ability to adapt. And there's certain genes that will say, like, hey, this gene right here will allow you to synthesize this type of sugar. And so when that gene turns off, suddenly it can synthesize a different type of sugar because that gene is no longer regulating like it should. And so there are times where we have this degrading of the genetics that actually helps the bacteria. And so he's been doing these evolutionary experiments, and what he's found is there's still bacteria, like, they never break out of this mold, but there's actually certain genes that when you turn them off, it benefits the bacteria in the short term. So really, really cool stuff. I believe Darwin Devolves is the book where you can read more about that. But Lenski is a guy who's been doing evolutionary-based experiments on bacteria. They've done other experiments where they've gotten fruit flies. And as you do fruit flies, again, they've bathed them in radiation, and they've done all sorts of things to them to kind of mutate, because evolution really has to work with two things. It has to work with what are called mutations, and it has to work with what's called natural selection. All right, and so the two of these are the backbone of evolution. Mutations are basically genetic spelling mistakes. Okay, So if you know anything about DNA, you know DNA functions on 4 letters. All right? A, T, C, and G. They can only pair with certain ones. All right? So if I have this right here, it's basically going to transcribe to this because they can only pair with certain bases. I don't know how much you guys know about science, so that's how it works. They also only pair in 3s. So you read 3 letters at a time, and that's how the DNA is copied and transcribed and all that wonderful stuff. So every now and then an accident happens where, let's say, instead of ATCG, it's ATTCG because it duplicates a letter. That's a mutation. It's a genetic mistake. It's a spelling error. And so what happens is, instead of saying ATCG, it now says ATTCG. And so when you pair that up, instead of getting that, like you should, it actually duplicates. And so now you're saying that. Okay? This could be a completely different amino acid, could be a completely different protein, which could create a completely different organ. Now, on the whole, 99 point whatever percent, it's actually probably going to kill the thing, if not just severely injure it. Okay? So every now and then mutations are going to happen. So let's say this is the coding protein for something like a wing. If you duplicate it, so you have ATC, ATC, so that happens sometimes where a glitch happens and it duplicates the material. You might end up with a fruit fly with 2 sets of wing instead of 1. Okay? Now, when you have wings, what else do you need in order to make those wings work? Muscles, nerves, etc. So if you don't duplicate absolutely everything required, guess what happens to that extra pair of wings?
It's useless.
Useless. Okay? So yes, they have actually gotten fruit flies, for instance, to have an extra set of wings. But outside the lab, they would die because those wings don't work. They don't have all the structures needed. In fact, we can get into some other time the details required to make a protein and some of these things, and it's absolutely ridiculous. Someone did the math. They said for one of these simple proteins, and again, only one protein, the number of combinations are actually more than the number of animals that have ever lived on the earth. So they're like, it's 1 to 10 to the 76th power or something like that. And there's been 1 times 10 to the 64th power animals, if we assume a 3.5 billion year old Earth. So if you had 1 try for each animal that's ever lived, there's not even enough animals that have ever lived to get 1 try to make this protein work. So that just some of the statistics kind of blow your mind after a certain point. But evolution requires mutation to work. Mutation happens all the time. Almost all of them are damaging. All of them result in, almost all of them result in a loss of information, okay? But again, mutations happen, 1, they happen so rarely, and 2, they're so rarely helpful that you're not going to see a lot of help coming from mutation. Then the other thing with natural selection, it is true that nature does some selecting. It's a entirely random, chance-based thing. But the problem with natural selection is there has to be something there for it to select from. Okay? And let me give you an illustration of how natural selection is not always helpful. In the case of some of those bacteria, some of the structures that will help bacteria survive only help them survive in certain areas. Okay? So one of the things we notice with evolution is something like antibiotic resistance. Have any of you ever heard of that before? Antibiotic resistance? Antibiotic resistance is this. When we started using antibiotics like crazy, we actually started to discover that bacteria gained the ability to resist the presence of antibiotics. Okay, so here's my bacteria. Here's my antibiotic, all right? When the bacteria absorbs the antibiotic, typically it targets a specific organ inside that bacteria and it kills that organ, which then kills the bacteria, okay? So that's normally how these antibiotics work. They target a specific structure inside the bacteria. If they can destroy that structure, it will trigger a chain reaction which will destroy the bacteria. What happens though is every now and then there's a bacteria who is missing that organ. Now, as you guys understand, normally when you're missing an organ, it's not actually helpful to you, okay? It's like, well, I can't have a heart attack because I don't have a heart. Okay, well, you're probably not alive either. All right, and so I understand there's certain organs you can't live without, but there's certain other organs that they're useful, but you can live without them. So like your appendix, you can't get appendicitis if you don't have an appendix. You don't have to worry about your appendix bursting if you don't have an appendix. But your appendix is actually really useful because what it does is it kind of like if you want to imagine it like a syringe, it kind of replaces all the bacteria and stuff in your gut when, you know, diarrhea and other things happen. It kind of recultures all of that, puts it all back in. But if your appendix gets inflamed and burst, you can no longer have that function, so you lose a useful thing. Okay? So there are some bacteria that an organ can be done away with, like it's missing. And so when the antibiotic tries to target that organ specifically, it can't. So guess which one of these bacteria is going to be the one that survives? The one on the right, without that organ. So this one's going to die, and so what you're going to see is now this one is the one that gets to pass on its genes to the descendants. And so now the population of bacteria, whatever that disease is now going to be largely antibiotic resistant because it is a survivor and it will continue to exist. Now, why this is not an example of evolution is this. These both probably pre-existed. They both probably already existed. It's just because this one had the organ, it was more prosperous because it had all of the structures it needed. In the presence of an antibiotic, this one dies off, which means now the population, instead of being 90 to 10, would probably be 10 to 90, or vice versa. I mean, that's how this is going to work. So you're going to see this bacteria just absolutely boom. But if you removed the antibiotic, what you'll find a lot of these times is this one, because it actually is being propped up by the antibiotic killing off all of its competitors, it may actually start dwindling again. Now that's not exactly something we want because the whole point is we're trying to kill it. But it may actually start dwindling again as the other one grows in population. And so that's kind of this thing where there are certain defects that allow you to survive better in certain environments. A stupid illustration I've used before is, imagine you step outside right now and the light from the sun kills anyone who can see it. What would be a mutation that would be really beneficial?
Be blind.
To be blind. Now, is being blind helpful?
No.
No. But if you were blind, would it help you in that situation?
Yes.
Okay. That's kind of a general, like, stupid illustration of how this works.
Mm-hmm.
Okay? And so there are times where mutations will step in and be helpful. There are even times where a damaging mutation will be helpful in the short term. So that's the thing. Like, as you study it out, so Darwin devolves is a good source for that. Oh man, off the top of my head. This one right here, Darwin's Doubt. Okay, so some of these are good sources that deal with some of those evidences for evolution and basically point out they're not as good as they make them out to be. Okay, and so this is the idea where we do see changes within a species, and we do see changes that sometimes result in an extra set of eyes or extra set of wings, all of that. That's no problem. Because what we found is everything stays within kind of a box, okay? That's why it's hard to define what a kind is, because we don't know exactly where on the animal kingdom chart it falls, okay? So you start off with the whole idea of kingdom, and then you have the phylum and the class and the order and the family and the genus and the species. We don't know where kind of in this family to species rank the kind is, but it's somewhere within that range. We don't know, okay? Because, again, this classification system was come up with way after the Bible was written. So it's kind of hard to put it back on and say, what did you mean by kind? Like, is it a bird kind? Like, is that like up here in the order? Or is it like a family level? I don't know. And so that's the thing. Like, you will notice birds always stay birds. Fish always stay fish. You know, there's a certain level of variety, but they don't go beyond that. Okay, that makes sense? Mm-hmm. Okay. And so as we study that out, there's just, we see a lot of change, but that will be more of what we call a micro evolutionary change. We don't see the macro. Okay, now just some notes here. Let's just see it in note form. Okay, Darwin's form of evolution, like I said, is the macroevolution. Another way of looking at it, that's biological evolution. It is one creature that changes into another type of creature over a long period of time. One of the handouts I'm going to give you in just a moment here will trace evolutionary history all the way back to 3.5 billion years ago. All right, and you can read through it to your heart's delight. I really don't care, but what it'll do is it'll give you at least one of the sources for this animal so many billions of years ago turned into this animal, which turned into this animal, which turned into this animal. And so that's kind of this progression that we see. That's macro evolution. It's big evolution. Evolution does not address the origin of life. Okay? So as we talk about evolution, has nothing at all to do with how life started. Okay? Now it's really fun because back when I used to teach science, we would talk about Louis Pasteur and all these guys who did all sorts of experiments showing that life can only come from other life. It is the law of biogenesis. Okay? Louis Pasteur and several other scientists did a ton of work disproving what they called spontaneous generation. All right? Spontaneous generation was this idea that, for instance, maggots could spontaneously generate out of rotten meat, or bacterial fungus stuff could spontaneously generate out of broth. And so what Pasteur did is he did experiments where he left the broth exposed to the air, but he made it so that dust and other things couldn't get in there, and he showed that life doesn't grow there. Like, life is not spontaneously appearing. It's something else landing in there that's causing this life to appear. So what he proved is life only comes from non-life. Other guys did experiments with rotting meat, where they thought, oh, maggots come out of rotting meat. It's just spontaneously generated. And they're like, well, no, it's flies laying their eggs, and that's where the rotting, the maggots come from. So they disproved this thing called spontaneous generation. In the process, they formulated this law, the law of biogenesis. Okay? The law of biogenesis is a law that states that life can only come from life. Well, here's the thing. As you talk to people who believe in evolution, they do believe, and it's outside the realm of evolution, admittedly, they do believe that at one point at least in history, there was what is called abiogenesis, which meant that something non-living gave rise to life. All right? And they say if you leave these proteins out long enough, they will eventually formulate into some sort of self-replicating form, and they will use all sorts of excuses to try to back this up. Again, as you study out the logistics of it though, on the whole, statistically speaking, these things don't arise spontaneously. Okay? They will use illustrations like this. They'll be like, well, crystals form spontaneously.
Crystals aren't alive.
Yeah, exactly. Or snowflakes will spontaneously form, and that's a very structured thing. How come proteins couldn't? Here's the reason. Crystals and snowflakes are what we call complex structures. Okay? They're very uniform. They have an organization to them that is very impressive. I think we'd all agree. There's a lot of things out there that are very complex. They're impressive. Okay? It'd be like if you opened up a book and it was like A, B, C, D, E, F, G, A, B, C, D, E, F, G, A, B, C, D, E, F, G. You're like, okay, that's complex. It's got a bunch of letters in there. That's awesome. But if they don't mean anything, if there's no specific meaning, that's not impressive. So, complexity can happen. But in order to have what we call information, we need specific, or specified is the way they like to call it, complexity. All right? And so as we get talking about things that spontaneously come into existence, complex structures do spontaneously come into existence. Crystals, snowflakes, those type of things, they do spontaneously come into existence. There's no problem with that. The world is run by natural laws. Natural laws tend to bring things into some sort of organization. However, when you start seeing language, when you start seeing specific meanings to things, that is something that actually shows evidence of information which does not come around spontaneously. Okay? Even as simple as the handouts that I'm about to pass out. There is a complexity here. There are letters here, but the fact is there are letters arranged in a specific pattern that shows evidence that there was someone putting that together. There's a designer here. There's a mind that is putting this stuff in place. The fact that you, using your mind, can translate this to make sense of it shows even more the intelligence that's required. Okay? Now I want you to imagine on a DNA level, you're looking at letters like that. And everything that we see is composed of massive strings of letters like that require computers to sort out. I mean, it's an impressively complicated thing. This is a specified, and it's complex, so it's a specified complexity. We're not just talking about crystals here. We're not just talking about snowflakes. We're not talking about lightning zapping a primordial soup and bringing a few molecules into, like, merge. When you start looking at what actually entails bringing something from a non-living to a living, it is more than just shock it a little bit and some things happen. Like, you are arranging letters, and then you have to arrange something to translate those letters, and then you have to have something that will regulate the translation of those letters so it can filter out the bad translations. That's all the stuff that's present. That's more than just you put a clay thing out there and you heat it up and some stuff starts to goop up on it. So that's what we're talking about here. But just so you guys are clear, when we talk about evolution, evolution picks up once life exists. So evolution has nothing to do with how life got here. Okay, so just so you're square, because that's a common thing that creationists run after, and they're like, well, how did life get here? It's a good question, but honestly, it has nothing to do with evolution. Okay, so just be careful. All right, also, another thing you want to avoid when you're dealing with creation evolution, just stop, because people do this all the time. They're like, well, evolution is just a theory, so, I mean, a theory is unproven. When you say that, you've shown that you don't know how science works. And I've heard it said a lot. No, in science, a scientific theory is pretty much certain. Like, in scientific lingo, theory is actually pretty definitive. So to say it's the theory of evolution is not to cast doubt on whether it's true or not. That's just what they call it. Okay? It's kind of like when you say, what is the proof for that? And you're talking outside of mathematics. You're showing you don't know how mathematics works. Because proof is a mathematical thing. All right? So just, these are some things you want to keep in mind. Another one that's a pet peeve of mine is when people are like, well, if we came from monkeys, how come you still see monkeys? Because evolution doesn't teach we came from monkeys. It says we and monkeys came from a common ancestor. It's a petty little thing, but if you're talking to an evolutionist that knows his stuff, you've kind of lost credibility. And so what I'm trying to teach you is some of these things that, yes, creationists are always going to be mocked. We're always going to be laughed out of the room. Nobody's going to take us seriously. Okay? However, you can at least know as much as you can so that you don't look stupid needlessly. Okay? So, just understand, there is evolution that takes place on the micro scale. Evolution has nothing to do with the origin of life. They might talk about it, they might try to figure it out, but they dodge the bullet by saying, oh, we don't have to figure that out. And it's like, you do. And then also, don't fall into the trap of, well, evolution is a theory, so therefore we don't even know. Like, no, like evolutionists believe it completely, as if it were a law, okay? All right, now, as we continue, nothing in the Bible demands long ages, nor really works with long ages, okay? So just understand that, like, evolution requires long ages to take place, because like I said, some of those proteins, the number of varieties that are required in order to make a protein work. Let me use this illustration. Let's say you have a lock, okay? So here's a bike lock. I know, worst bike lock drawing ever, right? But let's say you have a bike lock. Imagine how long it would take to figure out, if there were 10 digits you could guess, how long it would take you to figure out the combination to this lock. Just sitting there, like 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 0, 3. Okay, it would take you probably hours, if not days. Okay, so it would be 10 times 10 times 10 times 10. That's a lot. Okay, so just to put it in perspective, 10 varieties there times 10 varieties there times 10 varieties there times 10 varieties there. You do the math. This is 1 times 10. 1, 2, 3, 4. Okay, so it's basically 1 in 1,000. Oh, actually 10,000. Okay, so 1 in 10,000 chance that you're going to get it right on the first time. Okay, the simple protein, if I remember the number right, 1 times 10 to the 76th. Okay, so if you were to compare a protein to a bike lock, instead of 4, you're looking at 76. Just imagine how long you'd be sitting there, okay?
It's like 19 times the amount of time.
Well, actually exponentially more, because
Yeah. That's exponentially.
So
Exponential mess.
it's crazy. So that's why, as we talk about long ages, this is why evolution requires long ages, because in order for this to happen by accident, you need billions of years.
Yeah.
All right, it's crazy. Like, yes, if this were, you know, a 3-digit bike lock, you could probably sit there for 15, 45, maybe an hour, and you probably have a pretty good chance of getting it by accident, just by trying your numbers. But when you've got 76, that's stupid. All right, that's why it takes forever. Okay, now again, several theologians have tried to find ways to fit millions of years in. Some of these ways, some are known as the gap theory. Some are known as progressive creation. There's other ideas for it, but that is why millions of years is required, because evolution needs it. Okay, so places where they've tried to fit the millions of years in. All right, here are the days of creation. There are a lot of people who try to fit in kind of like right here. In fact, it's kind of like right before or after the first day of creation. So this could be the gap theory. And basically it's the idea that God creates the heaven and the earth and insert millions of years, and the earth was without form and void and darkness, you know, like, okay. And so basically the idea is there's millions, if not billions of years where stuff happened and then God destroyed the earth and then he starts recreating again. So that's like the first major idea, is this idea that there were a gap of millions of years between verse 1 and 2. So, okay, that's one idea. So the gap theory kind of falls somewhere in this first day or two, like right before or after it. There's millions of years worth of time slipped in. Some of them even believe there were soulless humans that lived there, and God destroyed them, and there you go. So there's that. There's another theory called progressive creation. All right. Progressive creation is this idea that, you know, God creates on day 1, lets it evolve for a while, creates on day 2, lets it evolve for a while, creates on day 3, lets it evolve for a while, comes in 4, evolve for a while. And so you've got various authors who would kind of lean that direction. I believe John Lennox would fall into this area. Maybe even Eric Metaxas. I'm not sure exactly on that one. It seems that way with some of what he says. But there's people who kind of believe that God steps in every now and then, and so the days of creation are more days that God created. They're not necessarily sequential. They just happen to be spaced out kind of across the span of time. All right, and so the gap theory, like I said, That's more of inserting a big gap of time and then let's carry on. Progressive creation is God steps in and just keeps doing things periodically. And then kind of a medley of some of this stuff is just this idea of theistic evolution. Now, depending on what college curriculum you used in high school, Abeka or Bob Jones or whatever, they'll kind of poo-poo the theistic evolution idea and be like, oh, no serious scientist believes it. I mean, maybe no secular scientist believes it, but I've known of a lot of theistic scientists who would buy into that. All right? But God does it. All right, and so that's kind of this. If you've ever listened to William Lane Craig do any debates, he kind of leans this direction where he's like, let's just assume everything science teaches about evolution is correct. God still is required. So you will even see me using some of this logic where I will use some of the evolutionary talking points and then show how even that requires a designer. Doesn't mean I believe it, just I'm using their ammo against them. So these are some different theories on what origins came from. Hey, yeah. Okay. Now, I'm going to summarize this. This is a handout that I just gave you basically on the gap theory. And it does fail on pretty much all accounts. Some of the reasons you can see there on page 1. It says that it puts death and suffering before the fall and the curse. We'll talk about that. Has not the slightest basis in the Hebrew, so there's not really a space in the Hebrew to be like, let's insert billions of years. Okay? It violates the tenets of historical grammatical exegesis, which basically means when you apply Occam's razor to the text, this doesn't work. Okay? Was never thought of from the Bible. It arose due to pressure from outside secular views. So it is made as an attempt to merge what the Bible says with science. And so it's kind of reading things into the text rather than reading out of the text. All right? It also fails to satisfy the people who don't like the Bible anyway. So if I hate the Bible, I'm not going to go, oh, sweet, gap theory, let me take that. I don't care. I don't believe in your God, so don't try to impress me. So it's kind of the idea of throwing your pearls before swine. All right? So you can read up on that if you really, really want to. But there it is. Okay? So that's just a little bit there about creation and evolution. And again, millions of years does not really fit in that text. Now, just a little bit. With the gap theory, one of the things that they go to is right here in the first verse of Genesis. It says this: in the beginning, God created the heaven and the earth. Verse 2, and the earth was without form and void. Okay? Without form. The Hebrew there is this idea of formless. It's tohu and tohu and bohu. So it's formless and empty. Okay? So as we deal with this idea of tohu and bohu, gap theorists, what they do is they look at this and they say, elsewhere in the scripture, the Bible says God he does not create anything void. And the Bible says in Genesis 1, after he creates, that it's void. So that means he didn't create it that way. It means it became that way because God had to destroy it because of all those soulless things living on the planet.
That's what it says.
Oh, yeah, sure. So here's the problem. If the earth really was without form and void, if we reference Isaiah 45:18, which I just did, then this is a recreation. So that's where they're going with this gap theory idea. They say, God says, I will not create anything void, and he created something void, which means it must be a recreation after it was destroyed.
So the gap theory believes in recreation.
Basically. Bohu, so this idea bohu of empty, actually appears a few times in the Old Testament. So it appears in Genesis 1:2, which we just read. It appears in Isaiah 34:11, and it appears in Jeremiah 4:23. You will see those referenced on the bottom of page 3 in your notes. Okay? Bohu basically means, instead of like became empty, it means uninhabited. So tohu means when God created the thing that will become earth, because it's not called earth yet, when he created the thing that called earth, it did not have a form yet because he had not started actually doing anything with it. He also created it empty, as in it had no life on it yet, so it was uninhabited. So as people start looking at these other texts and they're like, oh, God won't create things this way. Okay, he created it formless because it did not have a shape yet. It's like a ball of clay that you haven't done anything with. That's this idea. It's not the idea of wasted. It's just shapeless. It's bohu because it doesn't have anyone living on it yet. All right, and so that's where this is. It is not becoming uninhabited. It's just empty because it hasn't been dealt with yet. Okay, and so the whole idea of like, whoa, God doesn't make things in vain. Well, he doesn't. But when he first made things, they were empty because they did not have a shape yet and they did not have people living on it. So that idea, in fact, they sometimes almost retranslate those words to be, and it became empty and void. And it's like, no. It was, and then God did something with it. And so what this idea is God is creating this wasteland and then saying, let's bring shape to it. Okay, and that's the idea. If you go with Russel Humphreys, he's a scientist who's done a lot of work in this field. He actually believes that the Earth at the get-go was a giant ball of water.
At the get-go?
Yeah, yes, at the get-go. And so he's basically claiming that this formless void is a large ball of water, and when it says that darkness was upon the face of the deep, he's basically saying it's a massive ball of water, potentially light years across. So you could describe that as, yeah, that's deep. Because this is the reason. Without gravity, water doesn't take a shape. Water is this weird, like, ripply ball. But when you have enough mass, it would form into a tight ball because of gravity, and then it has a shape to it. And so when it says that the Spirit of God moves upon the face of the waters, it's basically the Spirit of God moving across the deep. That's his theory. I may play the video if I'm feeling particularly wanting to punish you guys. I started watching it last night, and the video panned to the audience at one point, and you could tell they were so into it. I'm just kidding. They could not look more bored. And so he has some interesting theories. He even accounts for potentially why there could be millions of years without violating the days of Genesis. So long story short, it works like this. He believes God created a gravity well that sucked the earth down in it while he was being created. And since one of the principles of extreme gravity is time slows down, he believes that God really could create in 6 days right here. And because of time dilation, the rest of the universe could have been running for millions of years in the time it took for 6 days to pass here. So that is a principle of relativity. And so he's like, then when God finished creating, he popped the earth up out of that gravity well, and that's why the earth could literally be 6,000 years old, but the rest of the universe could be millions, because...
Interesting.
Yeah, so, I don't know. It's just some interesting stuff. He's an astrophysicist, so he knows about that stuff, and so that's his theory, and I won't subject you to it unless we have a lot of time later on in the course. Okay, now as we move on, let's talk creation. At the beginning, according to the Bible, it really seems that the earth was a giant watery blob. All right? Yes. Now, here's how this works. If you look, it says, and the earth was without form and void. So that's tohu and bohu. And darkness was upon the face of the deep. So you get this idea of water. And then it says, and the Spirit of God moved upon the face of the waters. Okay, so you have some sort of watery globe. And so God is now taking that watery globe, he is shaping it, and he's doing something with it. All right? So as we begin this whole process of creation, you have a giant watery globe, and that is just called the deep. All right? Now, what this is probably referencing as well is some of the other myths from the area built on this idea that creation began with some primordial sea. Okay? You study Egyptian mythology, you look at a lot of other mythologies. A lot of mythologies come back to water. All right? Now, I'm not saying this isn't true. I'm actually saying this is what happened. But I wonder if some of those other mythologies got their idea for the water from the way creation actually happened, and they just twisted it a little bit. All right? Because what do you find in almost all the other mythologies in the area? The first god is the one who popped out of the water first. So in Egypt, you've got like the lotus that pops up out, and then the universe comes out of the lotus. You know, and you got all this other weird stuff. And
Out of the Lotus?
comes out of the lotus. It's really fun. It kind of looks like a light bulb if you see the pictures, which is why the ancient astronaut theorists go crazy. They're like, oh, Egypt had electric lights. And it's like, no, that's the universe being pooped out of a lotus flower, because that's how that worked. But what happens here is God is bringing into existence the deep, and now he's doing something with it. Okay, whereas most other mythologies, you've got like, in Greek mythology, you've got Mother Earth and Father Sky, and somehow they have a baby. Don't know how that works, but creates the first, Titan creatures, and they have offspring, and yeah, it's just weird. Okay, and but that's this idea of the deep. All right, and so the Earth starts out as a giant watery ball. Okay, and let's keep going with what happens now. Because of the surface tension, water tends to pull itself into a spherical shape, but there's no definite form or function. Okay, so if I can bring a little science, that's what happens. It is empty, which means there's no life on it. Okay, so when God creates this planet, it's just there. Now, some of the Hebrew does seem to imply that this happened before the events of the days of creation. Okay? So in fact, a very, very literal reading of Genesis 1 would be the idea of when God made the heaven and the earth. So it's the idea of when God did this, it was formless and void, and God said. So it almost implies that this could have sat for a while. We just don't know. But the fact is, we know there was no life on it until God stepped in and started doing things. Which is why we don't run to evolution and go, look, there's a place for evolution here, because no. If this watery ball existed for a long time, who cares? No life on it began until the days of creation. That make sense? Okay, so as he starts doing stuff, it's empty, it's void of life, but look what starts happening. First of all, it was dark because there was no light, and darkness isn't a thing. It's an absence of a thing, it's the absence of light. And so the first thing God does is he says, all right, this dark, formless void needs to have some light to it. And so the first thing I'm going to do is I am going to create light. And you can see why he needed to create light, because it did not exist. And light is actually a thing. It is photons. They're basically electrons and all of that good stuff, which are actually a thing. Matter and energy are exchangeable, and we're not going to get into a physics lesson, but light is actually something. Darkness is the absence of light. I don't know where antimatter came from, so don't ask. All right? Now, once he starts doing this, he starts creating, and the days of creation start coming through. So my next handout is my cheat sheet, so that you guys have some help on your project. You should have 3 pages there. And so you've got the progression of creation. You can see her on the handout. The progression of creation is going to change based on what chapter you're looking at. Genesis chapter 1 is going to lay it out in what I call the chronological order. Chapter 2 is going to lay it out more in the order of importance. Okay? And so you can see there, day number 1, he's separating light from the darkness, so he is creating light. Day number 2, he's going to separate the waters from the waters and create what's called the firmament. And then he puts the stars in the firmament, which is an interesting thing. Day number 3, he's going to gather the water together. He's going to create the dry ground. And this dry ground he's going to name Earth. Not the planet Earth, but Earth as in, I'm going to go dig in the earth. All right? Day number 4, he's going to create lights. So he's going to actually put the stars in the firmament. Day number 5, he's going to start creating animals. And you're going to see specifically the land and the sea animals. And then day number 6, he's going to create the land animals. So that's the order of creation as we find it in Genesis chapter 1. I believe that is the chronological order. It's basically God saying, I'm going to create this and this and this. What's interesting is you're going to see a pattern. Day 1, 2, and 3, he talks about, I'm going to make light. All right, and so you see that there on day 1, he creates light. Second, Oh, let me see where on your handout this is. It's a fun little pattern. Oh, okay, yeah. So right under point number 3, where I was looking. All right, so he creates the lights, he creates the heavens, he creates the seas, and then he creates the earth. So you see that kind of in days 1 through 3, he does that. And then days 4 through 6, he then populates those things in that order. So the light and the heavens, he kind of merges and he creates the stars and the moon and the sun. So basically the lights. Day 5, he populates the seas. And then day 6, he populates the earth. So it's just kind of a fun little pattern where he creates the place where they're going to be, and then he creates them, and they're done in that order. So that's fun. The other detail that you will see throughout, look at the very back page, so the place with all the footnotes. The very back page, it's this idea of what the 6 days of creation look like. And so you'll see this pattern where it says God said. All right, and so the first thing that God is going to do is he's going to say something. The second thing is he's going to say, let there be, which is what he said. All right, once he says, let there be, the next thing he's going to do is, there was. And then God saw, it was good. All right, so it's this idea that God looks out, he sees a need, he speaks the need into existence, and then he evaluates, and then he concludes. And you'll see that with each of the 6 days. That is why you will see that day 7 is different. Because day 7 is not a part of the creation week, per se. Day 7 is a pattern day. All right? So as you get to day 7, that's one of the things a lot of these progressive creation people will say. They'll be like, oh, day 7 never ends. Well, it doesn't fit the pattern of the other 6 days because it's not meant to. Every other day, God creates something, he evaluates what he's created, and then he concludes the day. Day 7, there's nothing being created, nothing that needs to be evaluated, and nothing that needs to end. So that's why day 7 kind of doesn't fit this pattern. All right, so that's a summary of the days of creation. We'll go through a little more detail there, but let me just show you in the mind. So as you read through the days of creation, this is more or less what the ancient Hebrew is going to think of as you read it, like strictly the way it's written. Okay? Now, whether this cosmology was what God had in mind when he wrote the words, or whether he wrote the words and then the Hebrews tried to make sense of it and this is what they came up with, I don't know. All right? So that's just, this is kind of an ancient conception of the way the universe would have looked. All right? So you kind of have the earth, and you have the mountains, and you have the sea, and this land that's all together. But you'll notice you've got the foundations, and around the earth is this wonderful thing called the firmament, which in its very word kind of gives the idea that there's something solid to it. And so it's the dome of heaven. It's a solid sphere that surrounds the earth. And so you've got the waters above the firmament, separated from the waters below the firmament. You've got Sheol, which is underneath the earth, kind of in the foundations or the roots of the planet. The clouds are up here, and you also got this wonderful detail called the windows of heaven. And so the windows of heaven, in the case of the flood story, the windows of heaven are going to open and the waters are going to come down. So that's kind of their conception of like what this rain is all about, because before that point they didn't have rain. And so it's this idea of like, oh, it's like God opened the windows of heaven and just poured all the rain down on us. All right? They viewed the sky as a vault resting on foundations. The world is viewed as a disk floating on the waters. Okay? Now remember, back then they didn't have the technology or desire to even climb up mountains, so they wouldn't have really gone up and like looked out over things. All right? And so they're just that language. And so this is kind of a conception as you read Genesis of what you're kind of looking at. Now, in reality, as we draw it up on the board, I'll show you what it more or less is. And you'll see how you can kind of say, all right, God is using the language of the people to make sense of what they're seeing. He's not trying to correct their cosmology. In fact, he may or may not have even approved of this. This may have been them just trying to figure out what the wording actually meant and not doing a very good job at it. So this is just something I kind of want you to picture. This is like an ancient person's conception of what they're reading. Not exactly in line with truth, but that wasn't God's point. All right, so questions so far?
So I don't think this, I'm just asking a point of discussion. Is there a possibility that it could have looked like that pre-flood and been changed into what we know now?
Probably not.
Right.
I mean, there's always the possibility. God can do whatever he wants. Because God is not necessarily in the habit or character of just like seismically changing an entire cosmology just for fun. He set a lot of rules in place. I mean, really a lot of our physical principles really wouldn't work.
Mm-hmm.
I mean, how does gravity work?
Right.
I mean, we don't know what gravity really is anyway, but we understand Earth isn't flat. So I don't think what happened is during the flood, God's like, and round Earth, you know, like, you know. So there's things like that that I don't think that's.
I'd say more like, are there people out there that?
Not to my knowledge. I don't think there's anyone who claims that, unless you're a flat earther.
Interesting.
If you're a flat earther, they got some weird ones. So that's, flat earthers have some weird ideas if you study it out.
Yeah.
So, but you can see here when it talks about Christ, when it talks about God walking upon the firmament or riding in the clouds, things like that, you can see how that. But I basically had a zoomed in picture, and it didn't.
Everyone but me has a boyfriend. I just realized that.
All right. All right. So let's get into the actual creation things. We'll come back to the days if I so desire, which I don't right now. With that note, I'm going to let you guys take a break. We will come back here in 5 minutes